All right, here are solutions to the first perfect problem for Math 251. We're given this function f of x equals 1 over the square root of x. And what it wants me to do is find f prime of a, still talking about a at this point in the class, using the definition of the derivative. Okay, so first of all, definition of the derivative. What that tells me is that f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. And as long as I'm here, difference quotient, something that will be relevant for future parts of this problem, tells me that f prime of a can also be found by evaluating the limit as h approaches 0 of f of a plus h minus f of a divided by h. So these are two things that will be relevant. I'll refer to these throughout the problem. But let's go ahead and get started. Part A says find f prime of a using the definition of the derivative. And that gives me some little hint here that presumably will be helpful at some point during the problem. All right, well, f prime of a is equal to the limit as x approaches a, just copying this up here, of f of x. Well, okay, let's write in what f of x is. Of f of x minus f of a over x minus a. Well, I know what f of x is. It's 1 over the square root of x. And I can figure out what f of a is, because if this is f of x, f of a is just change all the inputs, the x's, into a's. It's 1 over the square root of a. And I want to divide that by x minus a. So it's this limit that I want to evaluate. We've seen things kind of like this in class where you have fractions kind of inside of a fraction. Really rational expressions is what I should call these. And what we did in the past is we said, all right, let's make this all one fraction. Let's get a common denominator. Well, the common denominator in this case would be square root of x times square root of a. In other words, I multiply this side by root a over root a, and this side by root x over root x. And if I did that, I'd get the square root of a divided by the square root of x times the square root of a minus the square root of x times the square root of x times the square root of a. And that's all divided by x minus a. And I'm going to write it as x minus a over 1, so that it's kind of fractions over fractions. And what I now have up on the top, since I have a common denominator, I can just say it's root a minus root x divided by this common denominator. Yeah, I'll just leave it alone. The square root of x times the square root of a is the same as the square root of x times a. It's one of these exponent rules. If you know that, great. If you don't, turns out you don't even need it for this problem. So I'm just going to leave it the way it's written, although you could write that differently. And don't forget that this is the limit as x approaches a of this thing. So it gets me to here. And now I got a fraction over a fraction, so I can say it's the limit as x approaches a of root a minus root x divided by root x times root a times 1 over x minus a. Kind of running low on room, we'll jump back over here. So I'm at this stage right here. This x minus a is causing trouble because I want to change all my x's into a's, but if I do, this will be 0, and so I'll end up dividing by 0. So it's this that I need to cancel out. But I don't have an x minus a up in the top here, unfortunately. Be nice if I do, but I don't. I have square root of a minus the square root of x. What I need is x minus a. This is where this hint comes into play. It says if you have the square root of a minus the square root of x, and you multiply that by the square root of a plus the square root of x, you get a minus x. Not quite what we want, but pretty damn close. In other words, I'm going to multiply the top and the bottom. I'm going to say this is equal to the limit as x approaches a of root a minus root x divided by this root x times root a thing which is then multiplied by x minus a. So far I've just copied this over here. But then I want to multiply this by, so maybe I switch colors, multiply both the top and the bottom by square root of a plus the square root of x. And the reason I do that is, as the hint says, if you FOIL this all out, what you're left with is a minus x. Sorry, I should write limits. Sometimes I get a little lazy. This is the limit as x approaches a of, up top I just have a minus x. And on the bottom, you could multiply things together if you really want to. I'm not even going to bother. I'm just going to leave it as root x, root a, x minus a, root a, plus root x. Just some huge mess. And the reason I don't have to simplify any further is because I can cancel these guys out. Okay, not directly. A minus x is the same as negative 1 times x minus a. So really I'll take this one step further. This is negative x minus a. A minus x is the same as negative x minus a. Now on the bottom I got root x, root a. I'm going to run out of room. X minus a. Yep. I thought I was going to run out of room. All right, let me copy that next line down here. This is negative. This is the limit as x approaches a of negative x minus a divided by root x times root a times x minus a times root a plus root x. And finally, there's a reason we did all that. This and this can cancel out. Pretty close now. This is just the limit as x approaches a of negative 1 divided by root x, root a plus root x. Unfortunately, this is a limit I can evaluate. I can change all the x's into a's, and I won't get 0 over 0. I'll get negative 1 divided by, see, root a times root a is just a. Root a plus root a, because I'm changing all the x's into a's, is 2 root a. So, I don't know, something like this would be one way you could write the answer. Okay, I should probably speed up because that is already 8 minutes and I've only done part A. So part B says do the same thing, except now use the difference quotient. Fine, I'll do it. I'll even do it quicker. It's going to be the limit as h approaches 0 of, well, let's see, I got my difference quotient here. F of a plus h, that's 1 over the square root of a plus h, minus f of a, 1 over the square root of a, divided by h. I start out doing things the exact same. I get a common denominator by multiplying this side by root a over root a, and this side by root a plus h over root a plus h. And what that gives me is root a over my common denominator of root a times root a plus h on the left here. And then from that I want to subtract. On the right I'm going to have the square root of a plus h over that same denominator. I forgot to write limit. I can do that, I think. This equals the limit as h approaches 0 of this thing. This was all the top, and then on the bottom I just have an h, or if you want, h over 1. So what I have is this is the limit as h approaches 0 of root a minus root a plus h divided by root a plus h times 1 over h. You're like, oh, now can I make all the h's 0? Nope, because if you do, you'll still get 0 over 0. It's this h that's causing the problem. This is the thing that goes to 0. I have to figure out a way to get an h out of the top so I can cancel that h with this h. Fortunately, there's a hint. It says multiply the top and the bottom by the square root of a plus the square root of a plus h. Because if you multiply this thing, which is what I currently have on the top, by this thing, I'll just be left with negative h. So that's what I'm going to do down here. I'm going to say this is the limit as h approaches 0. You know what I'm going to do? I'm going to save a step. And over here, I'm going to multiply this by root a plus h divided by root a plus h. And what's nice there is on the top, when I FOIL this all out, I just get negative h. And on the bottom, I'll have a mess, but that's okay. Root a plus h, h, and then this root a plus root a plus h. Huge mess on the bottom, but that's okay because really all I wanted to do was get rid of the h, which I can now cancel and evaluate. This is equal to the limit as h approaches 0 of -1 divided by root a plus h, root a plus h. And now I can evaluate this limit. I can make all the h's 0, and I won't be dividing by 0. If this h is 0, I have root a, well, still got the -1 on top. I got root a times, this would just be root a. Root a times root a is just a. And then I would have to multiply that by root a plus root a. Root a plus root a is 2 root a. So I get here, which is the same thing I had up here. Whew, I might have made this problem a little too hard. Okay, there's A and B. Part C says use your answers to find, okay, so nice. At least I made part C really easy. Part C says find f prime of 4. Well, I know that f prime of A is this thing, so f prime of 4 is just -1 divided by 4 times 2 root 4. Change all the a's into 4's. Easy enough. Square root of 4 is 2. So this is 4 times 2 times 2. In other words, this is -1 over 16. And finally, the last part, D says use a graphing calculator to sketch the graph of this thing. Or you can just Google graph it. Sure, I'll do that. Close my baseball game. I'll go to Google, and I will say graph. What's our function? 1 divided by, I don't remember what we're graphing. It's x divided, okay, x raised up to the -1/2 power. Because x raised up to the -1/2 power is the same as 1 over the square root of x. So anyways, the graph looks like this. The scales are a little bit off, but the basic idea is that at this point where x equals 4 here, the slope of the tangent line at x equals 4 would be equal to -1/16. So maybe I will just say, maybe note slope of tangent line to graph at x equals 4 is exactly equal to, looks like, I'm just going to say is -1 over 16. If we drew the tangent line to that graph we had at x equals 4, the slope of that line would be -1/16, which is what this thing is showing you. Whew, all right, that's finally the end of this.